Hello and welcome. Today, we're diving into a really key concept for your AQA A-level psychology exams, the skin conductance response, or SCR for short. It's one of the main physiological ways we can actually measure stress, so let's get right to it.
So let's start with a feeling I'm pretty sure we all know. That moment just before a big exam, or maybe a presentation. You get those clammy, sweaty palms, right? It's just a classic physical sign of being stressed out or nervous.
Well, that feeling is actually your body's fight or flight system kicking in. But see, that's a subjective experience. Psychology, as a science, needs objective, measurable data. So the big question is, how do we take that internal feeling of stress and turn it into a number we can analyze? And that, right there, is exactly where SCR comes in.
Okay, here's our plan for this explainer. First, we'll look at why we want to measure stress objectively. Then, we'll nail the core knowledge you need for AO1. After that, we'll apply it to the real world for AO2, and then we'll get into the critical evaluation for those all-important AO3 marks. Finally, we'll wrap it all up with a final verdict. You know, when we want to measure stress, we could just ask someone, right? Have them fill out a questionnaire. But the problem with that is you're relying on them being totally honest and, well, aware of how they truly feel. Physiological measures like SCR are different. They kind of bypass all that by looking directly at what the body is physically doing.
And there are a few ways to do this. We can measure heart rate, blood pressure, even the level of the stress hormone cortisol in someone's saliva. But the one that the AQS specification really wants you to know inside and out is this one, the skin conductance response, or SCR.
All right, let's get into it. This next part is pure AO1. This is the core description, the essential knowledge you just need to have locked down for your exam. So what on earth is skin conductance? Okay, at its very heart, SCR is all about measuring how well your skin conducts electricity. Now, the crucial link is this. When your nervous system gets stressed, it tells your sweat glands to get to work. And even a tiny, completely unnoticeable amount of sweat makes your skin a much better electrical conductor. It's that change that we can actually measure.
Let's break that biological chain down step by step. First, your brain perceives a threat. An exam paper, a scary movie, anything at all. This immediately kicks your sympathetic nervous system into gear. That's your classic fight or flight response. This instantly stimulates your sweat glands, especially on your hands and feet. That little bit of moisture increases how well your skin conducts electricity, and boom, that's the signal our machine picks up. It's basically a direct line from a thought to a measurable physical change. Pretty cool, huh?
Now, it's important to know that researchers look at two different types. First, there's the tonic level. Think of this as your baseline, your skin's normal conductivity when you're just chilling out. But what's more interesting for stress research is the phasic response. This is the sudden spike in conductance that's triggered by a specific event or stimulus. That's the signal we're really looking for. And we've got some really solid evidence for this. A classic study by Lang and his team back in 1993 showed people a bunch of different images. And what they found was, when people saw emotionally charged pictures, something scary or exciting, their phasic SCRs were way stronger than when they saw neutral, boring pictures. This is a brilliant piece of evidence showing that SCR is a really sensitive measure of our emotional arousal. Okay, so let's shift gears now to AO2. This is where we start to apply all that knowledge. Showing you can do this is how you demonstrate you really get it. So let's look at some real-world examples you could use in an essay. Let's go right back to that exam hall. Imagine we could hook a student up to an SCR machine. We could literally track their stress levels second by second. We'd probably see a spike when the paper is handed out, and maybe another one when they hit a question they find really tough. This kind of objective data is incredibly useful for researchers who are testing if things like mindfulness or breathing exercises can actually help reduce that exam stress.
And here's probably the most famous, or maybe I should say infamous, application of SCR, the polygraph test. A lie detector isn't magic. It's just a machine that measures a bunch of physiological responses, and SCR is a key one. The whole idea is based on one simple assumption. Lying is stressful, and that stress will show up as a spike in skin conductance. But is it really that simple?
Well, no, and this is the fundamental flaw. Just look at this. An innocent person who is terrified of being wrongly accused, they could show a massive SCR spike and get flagged as a liar. Meanwhile, a cool, calm, practiced liar might show no response at all and be seen as telling the truth. So here's the crucial point you have to remember. The machine measures arousal, not deception. And that is a huge, huge difference.
This leads us perfectly into AO3, critical evaluation. This is really where you earn those top marks, by weighing up the good and the bad and showing you can think like a proper psychologist.
So let's break it down. On the one hand, SHER is great because it's objective and it gives us real numbers to work with. It's got high temporal resolution, which is a fancy way of saying we can see changes happening from 1 second to the next. And it's fantastic for triangulation, which just means combining it with other methods. But the limitations are pretty major. As we've said, it measures general arousal, not a specific emotion. It could be thrown off by random stuff like the room temperature, and let's be honest, studies in a lab might lack ecological validity.
This quote right here really nails the main limitation. That spike you see on the screen? Sure, it could be fear, but it could just as easily be excitement from figuring something out, or anger at the question, or even just the mental effort of concentrating really hard. Without more information, we're just guessing what that spike actually means. And we can link this straight to our grave criteria for evaluation. Lab studies that use SCR can be highly reliable because the conditions are so tightly controlled, but that artificial setting being wired up to a machine, well, it has pretty low ecological validity. We have to ask, do these results really generalize to the messy, complex stress of real life? That's a critical question for any evaluation.
So where does all this leave us? Let's pull all of our AO1, AO2, and AO3 points together and try to form a really strong, sophisticated conclusion. Is SCR actually a powerful tool for measuring stress?
The best answer really lies in this concept, triangulation. In research, this just means you never, ever rely on just one method. You combine them. You take the objective data from SCR, but you also use a self-report questionnaire to ask people how they feel, and maybe you'll even add in some behavioral observations too.
So the main takeaway is this. SCR is a brilliant tool. It's precise, it's objective, and it gives us this amazing little window into the body's immediate stress response. But, and it's a big but, it is only one piece of the puzzle. It just doesn't tell us the whole story of what a person is actually experiencing. And here's how you can structure that perfectly for a top-band essay conclusion. Start with its strength. It gives us objectivity that self-reports just can't. Then, hit it with its key limitation. It measures non-specific arousal. Your solution? Triangulation is the best approach. And your killer final point is that this combined approach gives us a full, complete biopsychosocial picture of stress. That is a fantastic, well-balanced argument. So I'll leave you with one final thought to chew on. If a machine says your body is showing a stress response, but in your own mind you feel totally calm, who's right? The objective data from the machine or your own subjective experience? That, right there, is the puzzle at the very heart of measuring something as complex as stress.